Hello, welcome back to the Advanced Artificial Intelligence. The topic is Transformer Encoder. This is part four. We have three previous parts. If you want to understand this part, then you need to go back to other parts. Now, this part is about the this layer. I mean, we have talked about in the previous part, we talked about encoder in general and decoder in general. So we talked about this. So that's part one. In part two, we talked about the positional encoding plus input encoding. Then in part three, we talked about multi-head attention. Now, in this part, we will talk about this layer, add and norm, this layer. So we talk about this layer, add and norm. So this layer exactly. That is the focus of this class or video. Now, residual connection, which is that is add and norm. Uh, so after step of multi-head attention, then we have to compute everything numerically and in the encoder. So we might have in the large language models, we might have many um, um, encoder layers. So here, the way that we do it, we will have the input, original input, um, which is going into multi-head attention, and the output from multi-head attention. So the output of multi-head attention plus the original input, I could say. So the original input is this 1 3 by 4 matrix. We had it, if we recall it, and recall again the output of multi-head attention, which was this one. And then we try to add element-wise of this to this, and element-wise of this to this, and so on and so forth. So that's the basic idea. So why we doing this? Why we get output whereby Z, the original input, plus the input that was the output of multi-head, the input that was used to get the output from multi-head attention. Why we are doing this? For many reasons, but the most important that we would use operation of element-wise. So each value, as I mentioned, will be added. Each value here will be added to the reflected value in multi-head. Each value here will be added to the reflected value or its reflected value in the multi-head attention. That's the first reason. The second, we are trying to avoid vanishing gradients, which is a problem in backpropagation learning algorithm. So, would help gradients flow during training. Now, also uh, preserve information. So we will keep original information about each token. So original information is kept here. So point two. So this is the original information about I. This is about the sentence like, and this is about Rojava. So we keep original information. Okay, so that's also important. And enable deep networks. So we're allowing stacking many transformer layers reliably. So we put, we keep stacking many uh, layers of transformer, and the transformer does not replace the original information. So we preserve original information. That's the idea, and we add new learned information to refine the representation. So that is so we add now each element to the other, and that's how we do for I, we do Z plus multi-head. So this one with this, and 1.1 with this, and 0.7 with this, and 1.3 with this. So that's how we do it for R1, residual array, and we get for the like R2, and we get for Rojava R3. So that's the results of this layer, which is residual, which is skipping a layer, and we add original to the output of the multi-head attention. Now this is done again. This is done. This is done, and we did the add. Now we need to do the norm. So we are in this process, which is in yellow color. So add is done. Add residual, and norm still we haven't done it. So we will keep going with doing the um, normalization. We call layer norm, and it can be done by calculating the mu, the mean, which is 1 over t, the number of uh, observations. So, so I to the 1 till d, and we sum up every cell in each row. Okay, for each row, we sum up the observation. So, and this is how we compute the variance. It'll be observation minus mu, square them, and over the d. That's how we get the normalization. Um, so x minus mu over the variance, and variance is computed from here. Now, eta could be usually assumed as uh, 10 to the power minus 5, and you might have also y equals gamma xi plus beta. Beta assumed is 0, and gamma is 1. So that's how we get the final output normalized vector. Now let's do the first row, this one, 3.125. This is we got it from here. If the residual. Uh, so we add this to this and this and this. So let's do it for the first row. We add this, this, and this, and divide it by 4 because there are 4 samples. Okay, and then we get mu. Now compute deviation. So the value itself minus mu 5.4. So each value in the row minus the mu, we get the kind of deviations. Now, if we square the difference that we found, that these are the difference, square each one of them. So square, 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 and sum them up. We get and divide by 4. This is divide by 4. So we get 9.687 divide by 4 because we have 4 elements in the row. So we get the um, the the variance, and square root of the variance is 1.556. Now divide the observation minus over the variance, we will get the first row normalized. So how we get this value minus 234 minus 2.345, it is actually this one minus 2 3. So the value x minus mu, that's how we get this value. Now divided by variance, we will have the first row. Same thing, we can do the same process for the token 2, for the word 2, which is this one like. That one I. we did it. For the like, we say that our synthesis, I like Rojava. If you just check earlier um, uh, parts of our classes. So we have token 1 is I, token 2 is like, and token 3 is Rojava. Now we are in the token 2, same thing. We um, we add them up and divide by 4 because there are 4 elements. We get mu, and now each value of each cell uh, minus mu, we get the variance, okay? And sum them up, sum these up, divided by 4, you get the variance, and square root of variance, you'll get standard deviation, and then uh, each value, each value of this divided by 1.39, you'll get the second row normalized. Likewise, we do it for Rojava, this token tree, Rojava, a word Rojava. Now add them up, divide by 4, you get this one. Now each value minus 5.25 to get the difference, and then sum them up, square them, and then sum them up and divide by 4. You will get the final layer output, this one. So that's normalized for this session. So we've done so far. We've done this and this. And I mean, we explained encoder and decoder in part 1 of the videos that we had it. And then in part 2, we talked about uh, uh, this one, positional encoding plus input embedding. In part 3 of our videos, we talk about multi-head, and this class we talked about add and norm. So next class we talk about feed forward. Thank you very much. If you have anything, please see the links and information there. Stay tuned. Thank you.